Is it recording?
Action!
You have to go away now. I can't do it with you there. Hey everybody, welcome to Geo Friday 3. Today we're going to be talking about aquifers. Last week we delved into permeability and porosity and what those terms mean. And this week we're going to explore a little bit of the High Plains Aquifer system and the geologic settings that created that system. So I just want to preface this talk by saying a lot of the information is coming out of this awesome publication. It's called the Groundwater Atlas of Nebraska, and it was published by the very smart folks at Conservation and Survey Division in the School of Natural Resources here at UNL. And it draws on decades worth of geologic and hydrogeologic data, and it's just a really great all-around Groundwater 101 resource. There are some really great graphics in here that I'm going to use to help talk about groundwater, so thanks a lot to the folks who made this resource available. If you recall from last time, an aquifer is a body of water-saturated sediment or rock through which water can move readily. There are two different kinds of aquifers, unconfined and confined. An unconfined aquifer has its upper water surface at atmospheric pressure, meaning it can rise and fall. This upper surface is also known as the water table. Since unconfined aquifers are usually closer to the surface, they are impacted by things like drought and contamination more easily. In some places, stream channel bottoms are above the water table, and water moves from the channel into the surrounding area. This is called a losing stream. In other places, a channel bottom is lower than the water table, and water from the subsurface moves into the stream bed. This is called a gaining stream. Confined aquifers are typically deeper below the land surface and have impermeable sediments above and below them, causing them to be under pressure. When a confined aquifer is penetrated by a well, water will move from the high to low pressure and rise above the top of the aquifer. We'll get more into this next time when we talk about well construction. Groundwater is the source of drinking water for almost half of the entire population worldwide. This map shows principal aquifers across the world. The varying colors denote rates of depletion or recharge the aquifer experiences annually. And since precipitation is the biggest source of recharge, you can see the impact of using water faster than the aquifer can replenish itself in arid regions. So if you look at the northern Great Plains Aquifer, it's replenishing itself by about 5 millimeters per year. The Californian Central Valley Aquifer system is losing water at a rate of 9 millimeters per year. And here in the middle, the High Plains Aquifer is staying pretty stable, right about 0.31 millimeters per year. So not a lot of change. Now let's look at some geologic events that shaped this part of the world. About 70 million years ago, during the Cretaceous period, sea level was much higher and the mid-North American continent was bisected by a shallow sea, known as the Western Interior Seaway. Rivers flowed from the highlands into this sea, leaving well-sorted sands and gravel deposits. Later, the climate cooled and ice sheets covered a large portion of North America, with the terminal lobes dipping down where the green line is drawn here. As the climate warmed, the ice sheets retreated and they left behind poorly sorted glacial till. The pink here shows the parts of Nebraska underlain by the sands and gravels left by the Western Interior Seaway. As the sea waxed and waned, it left deposits in cycles of sandstone, shale, limestone, and mudstone. The pink in the top map is the Shadron Aquifer. When the Cretaceous sediments were eroded, they created a landscape of rolling uplands and valleys that were later filled in by the sands, muds, and gravels of streams, lakes, and wetlands of the Eocene, some 40 million years ago. The blue on the lower map shows where the High Plains Aquifer underlies Nebraska, spanning roughly 84% of the state. It's often referred to as the Ogallala Aquifer, although it actually includes many aquifers of different ages stacked one atop another. The eastern portion of the state is characterized by river valleys that deposited abundant sands and gravels, known as paleovalleys. But they were then buried by glacial till several thousand years ago. If you recall from our sweet potato exercise, glacial till is not a good home for groundwater, and it acts as an impermeable layer on top of the highly permeable sands and gravels below. This makes the Paleovalley aquifers confined aquifers. Next week, we're going to talk about well construction, and we're going to look at what happens to the surrounding aquifer and groundwater table when we start pumping from that well. See you next time.